What a quark is. What is a quark really? Textbooks usually say it is a smaller point inside protons and neutrons, then jump straight to equations. No picture, just symbols. In energy filament theory, EFT, a quark is the smallest and most fragile little filament ring the universe allows, and it carries a badly unbalanced straight texture in the energy sea. That built-in asymmetry is exactly why a single quark almost cannot exist on its own. Build the picture from the start. Imagine dropping a very tiny filament ring into the energy sea. If the ring is wrapped symmetrically, like the electrons' balanced pattern, the sea can support it. The ring tugs evenly, so it can settle into a stable state. A quark ring is different. Its straight texture leans heavily to one side. The inner and outer tension are not balanced. It is like pinching a rubber band into a crooked little loop. While you hold it, the shape stays. The moment you let go, it snaps. In F terms, a lone quark is born unstable because its texture is skewed. The energy sea pulls harder on the heavy side, so a single quark appears quickly and collapses even faster. The sea will not calmly host that pattern. So why do quarks seem to stay around in nature at all? Because they almost never show up alone. 3 quarks can line up their crooked textures so that each one partly cancels the others. Think of 3 odd puzzle pieces whose jagged edges just happen to interlock. Once they bite together, the total pattern becomes much more symmetric. In this joined state, the 3 asymmetric textures twist into what you can picture as 3 tension bridges, stretching through the energy sea between the rings. Add the mutual support from the 3 rings themselves, and you get a surprisingly tough bundle. That bundle is what we call a proton or a neutron. Now pull on one quark and try to drag it away. The tension in the bridges rises as you stretch them. Instead of snapping, they pull tighter, and the energy cost climbs. At some point, it becomes cheaper for the sea to roll out a brand new pair of quark rings than to let the original bridge break. You never see an isolated quark. You just see the system reshuffle partners. This is quark confinement in EFT. It is not that quarks are locked in a box. The composite structure itself refuses to let a quark exist alone. The famous color charge of quarks becomes simple in this view. It is just the 3 complementary directions of those crooked textures. All 3 must be present for the bridge network to be balanced. Lose one, and the little fortress falls apart. Next episode, the proton as a 3-ring stronghold in the energy sea. Tap follow, share it on New Physics, Clear Universe.